Alright, let's see. Let's do another one. How do you solve this one? Normal Sudoku rules apply, so 1 to 9 in every row, every column, and every 3x3 box. The sum of digits on a region sum line, these blue ones, is the same for each box, so occupies... so basically what it's saying is that this sums to these three, this sums to these three, which sums to that, and then these sum to these three, and so on and so forth. Digits adjacent along a green German whisper line. So digits that are adjacent to each other, these two digits, and these two digits, must differ by at least 5. So if this was like a 6, then this must be at least 5 away, making that a 1. And digits separated by a black dot must be in 1 to 2 ratio, so one is double the other. Digits separated by a white dot must be consecutive, so you could have like a 3, 4. Pretty standard rules. We've been looking at that for like basically the entire stream now. Oh, welcome back, Lugia. I solved the previous puzzle. It was like a blast. It was pretty cool. Oh, I liked it. Not all dots are given. So those are the rules. I guess we'll start now. Let us begin solving. Okay, so in each region sum line, I noticed that all of these are 3 cell digits which sum to 1 cell here. These sum to the 1 cell here, and these sum to the 1 cell here. That's pretty interesting because those mean that they all only have 4 possible options, which are 6, 7, 8, and 9. The reason why is because minimally here you could have a 1, 2, and 3. Means that because these sum to that cell over there, this has to be a minimum of 6. And I think we can do a bit of coloring here because these two must sum to the same value. Because this sums to this. And now, whatever these are, they can't be pink, so let's make that a different value. This can't be orange or pink, so let's make them another value. Oh, they don't have to be equal, I just realized that. Yeah, they don't have to be equal, but these are definitely not pink and not orange, so they're either, well, let's say either green or blue. And then this one, well, this one could be anything. It could be green, blue, or pink. It could be any of them. But this now is double of that, so actually, I mean, this is in a 1 to 2 ratio. Yeah, so this can't be a 7 or 9 because we realize that 7s and 9s cannot appear on a black dot. And then here we have some similar issues. So 7 and 9 cannot appear on black dots. This one was a 6-8 pair, which means that this, which is different from orange and pink, cannot be 6 and 8. So they're all 7 or 9. We also know that these, well, if it were a 6, then the other digit would have to be a 3. And if it were an 8, the other digit would have to be a 4. Right, and because these are no longer 9s, then these must have a 1 on them, because if you had no 1, then it will be 2 plus 3 plus 4 at least, which is at least a 9. So each of these must have a 1 in them somewhere. We can't say the same about these ones though, because those could in fact be 9s. Okay, what now? Oh, okay. Yes. Where does pink and orange go in this box? Pink can't be in any of these cells, so pink goes in one of these boxes. Orange actually does the same thing. It can't be in any of these cells. Oh, right. Orange can't be here. Obviously pink can't be here because you can't have pink plus something add to pink. But orange also can't be here because orange is at least a 6. And 6 plus 1 plus 2 minimally adds to a 9. So these can't be orange either, meaning that's where orange is. So this is a 6-8 pair because we know orange and pink are 6 and 8. Okay, how does that help? Ah, I see. Where does orange go in this box? No, wait, what? No, what am I saying? Orange could be 8. Yeah. Okay.
Where you go, I go.
What's this? Okay, never mind. What am I doing? These are two different values. Does that help?
That's you, alright?
Okay, where was I? I know what I was saying. Right. Okay, back. I was looking at this and I realized that this can't be pink. Because if this was pink, then where does pink go in this box? These all point to pink being in here. But we know pink cannot appear in orange because even if this was 6, 6 plus 1 plus 2 sums to at least a 9 already. So this can't be pink and it can't be orange and have to be blue and green somewhere. So in fact, because whatever this is, this must be different from it. These two must be the same. And therefore these two must be the same. And because it can't be 6, 8, it has to be 7, 9. There you go. Math. So okay, what does that do? I mean, I think it sort of works itself out, but green is in one of these cells, and then blue is in one of these cells. But we can't figure out which one. Is this similar? No, it's not similar. Because we know green is in one of these cells, yeah. But then blue doesn't have that similar issue with this one. So blue can be like in any of these cells. So that's something that's a bit off, I think. I guess where does pink go? Pink can't be here. No, but yeah. Pink can't be here because even if pink was like a 6, this has to be at least 3. So 6, 3, 1 makes this at least a 10, which fails. So pink is one of these cells. How does that even help at all? And pink will be in one of these cells. But again, not very helpful. And this time, this is possible for this to be for this to contain a orange, because you could have a 6, 1, 2, and then those adding up to 9. I think this barely works, so orange can in fact go on the line, which means that orange doesn't have to be here. So that's a little frustrating. I think 2 has to lie on this somewhere, although I don't think that really helps. There should be something very obvious that I'm not seeing, otherwise this wouldn't be like an easy puzzle at all. Is it this German Whisper? I mean, maybe it is. Maybe it's also this. It might be actually, yeah, because it can't have a 6 or an 8 on it, so this immediately can't have a 3, 6. It can't have a 8, 4 either, so it's either a 1, 2 or 2, 4. And in either case, 2 has to exist on here somewhere. Ah, and this can't be 1, 2. Because if this was 1, 2, then this is minimally 3, 4, 5. And 3, 4, 5 is at least 12, so this can't be a 1, 2. So it is a 2, 4. And this is always a low digit no matter what. I'll use light blue for low digit. You can barely see that, wow. Okay. I guess I'll still use I'll use red and yellow. So low digit will be red. And because this must be at least 5 away, then this would be a high digit. And then this would be a low digit, and then this would be a high digit. Because that's how German whispers work, you're always alternating between low and high. This digit is at least a 7. Because it is at least a 2 here, so this must be at least 5 away. So it's either a 7 or a 9, which is very useful because it can be an 8. And then this has to be, well, it can't be a 1. So it has to be at least a 2. It can't be a 5. And in fact, it can't be a 4. Because if it were a 4, then these both would have to be at least 5 away. So it would both be 9, which fails. So this can't be a 4, and it has to be only 2 or 3. And then this would have to be at least a 7. So this is either 7, 8, or 9. This can be an 8 though if the pink was like a 6, I think. If the pink was 6, then this could be an 8. So that helps. I think, yeah, we'll keep the color. But the 2, 4 here does help give us our first digit. Wow, after 15 minutes, that must be a 3 because it can't be a 4. This must be a 6. 6. Oh, and these are in fact 8. Not 6, 8. Can it not be an 8? It says at least 5. Which one? This one? There's a 6, 8 here, so putting an 8 here would remove 8 from any of these, and they will both be 6s. Yeah. Alright, so pink is now 8. So that can't be an 8. This is now, well, an 8 is in one of these cells. Okay, well, what am I doing with the colors? Let's remove the colors. Because these are 7 and 9, so it have to be either green or blue. And this green here means that can't be green. So that's a blue, that's a green. I'm doing a lot of coloring here. I love my coloring books. Oh, so this can't have a 3 in it. Because a 3 would then be beside a 7 somewhere. And then that would be only 4 apart. So it can't be, it has to be a 2. That helps. This has to be a 4, it has to be half of 8. And then these have to be 1, 2, 3 because it has to sum to 6. This can't be a 2. This one has to be a 1 and then a 7, but then the 7 has to be a 3, 4 or a 2, 5. But it can't be a 2, 5, so it's 1, 3, and 4. Yeah, so cool. I don't know what I'm doing. Yep, without a 2 or 4 here, this is minimally 135. And 135 adds to 9, so it just has to be 9. So all the blues are now 9s and all the greens are now 7s. This is therefore a 124. It can only be that. 7 is in one of these cells. In this box, where does 7 go? All of these cells are seen. That's not a 7, so 7 is there. Where does 9 go? 9 sees those cells, this 9 sees that. These can't be 9s, so 9 goes there. So I'm missing 5, 6, and 8. 5, 6, 8. 1, 3, 4 means that it's not a 1. That's a 5. That's a 1. The remaining cells here are 8. Oh, I just blanked out. What are the remaining cells here? 8, 6, 9. This can't be 6s. This can't be 8 or 9, so that's a 6. This is an 8, 9 pair. This 9 resolves that, so that's an 8, that's a 9. I can remove the color, I think. That is therefore a 7, which removes 7 from that. So that's a 7. Do you hear that? Someone's honking the horn outside. This 6 means now these are 6s. So that's a 6. Yeah. Jeez. They really have to stop honking. What are these cells? They are 1, 3, 1, 3, 5? 1, 3, 5. This can't be a 1 or a 3, so that's just a 5. And then these cells are 4 and 5. 4 and 5. These cells are 2, 7, 9. So that can't be a 9. 5, 8 here removes a 5 from this cell, so that's a 4, that's a 5. Bruh. Okay, we still haven't resolved this one yet. I don't think we can right now. Nope, I don't think so. What was this cell? Where can 6 go? This 6 sees those cells. This 6 sees those cells. These can't be 6, so that's a 6. And then in this box, this 6 sees that. These two 6s sees those. This 6 sees that. So that's a 6. And then where does 6 go in this box? That's a 6. That's a 6. That's a 6. So 6 is in one of these cells. But this can't be a 6, can it? Because if it was a 6, then this had to be adjacent to that. Or this would have to be consecutive. So it would either have to be a 5, which doesn't work, or a 7, which also doesn't work. So that can't be a 6. That's a 6. And then here, in this box, 6 can't be here, 6 can't be there, 6 can't be here, so 6 in one of these cells. Now this can be a 6, because this can't be a 7, but it could be a 5. So that's not resolved. Unfortunate. What else do we have? 7s? Mayhaps we have them 7s. No, I don't think so. 7s could be like anywhere at all. And then I don't think we're gonna use much of the region sum lines anymore, except maybe this one. These sum to 9. They could have any digit on them though. I guess the only thing they can't be is 1, 2, and 6, but it could be like 1, 3, 5, could be 2, 3, 4. Could be anything. What about these? These are 1, 2, 3, and 5. This can't be 1. Oh no, I think I'm not doing this right anymore. Yeah, I'm not doing this right anymore. What am I doing with all these pencil marks? That's not cool. Wait, so what am I supposed to do? Isn't this just normal Sudoku? Is there something I'm missing? Like say, where does 9 go in here? Oh yeah, where does 9 go in here? These are all not 9s, so 9 is just there. And then these 9s, see those, so 9's in one of these cells. And then here, oh, 9's in one, 9's not in here because these sum to 9. So then 9 is in one of these cells. But then we already have 9 of those cells, so that doesn't work either. Oh, what are these? I just realized, yeah, 8 over here sees those cells, so that's an 8. Then these are therefore 5 and 3, 3 and 5. This is therefore a 1, 2, or 4. As per usual. Nothing else, I guess. This is 1, 2, 4, or 5, as per usual. 1, 2, 4, 5. Ah, this is also... No, this is 1, 2, 3, 5. And it can't be... So it's either 2 or 3, because it can't be 1 or 5. This is... So... This 1 means that's not a 1. I think I should have seen that a long time ago. But it doesn't really help. A 1 here puts a 2 there. And a 2 here can't put a 1 there, so a 2 here puts a 3 there. A 4 here can't put a 5 there, so a 4 here puts a 3 there, and then a 5 can't put a 6 here, so 5 puts a 4. So this is either a 2, 3, or 4 only. Yeah, in fact, where does 8 even go on this column, or on this row? This 8 sees that, and this is clearly on 8, so 8 is just there. That helps disambiguate this one. So this can't be a 5, meaning that in this row, 5 has to be there, which has to be consecutive to 4, so those are 4s. This 4 sees that, so that's a 2. Phew. So that is a 3, I think. That's no longer a 3. This is a 1, 2, 3. Wow, okay. This can't be a 1. This can't be a 1 from that. It can't be a 2 from this. So that's just a 3. Okay. This is a 1, 2, or 5. A 1 puts a 2 there. A 2 puts a 1 or 3 there. And then a 5 can't put a 4 here, so 5 will put a 6 there. So this is either a 1, 2, or 6. No, a 2, 3, or 6, sorry. 2, 3, or 6. It's not really that much of a help either, though. Four? No. What are these cells? These are 5, 7, 8, 9. Oh, that's interesting. 8 can't go here because then these have to be at least 11. 8 can't go here because of that. So in this column, 8 goes here and here, which means that just like 9, yes, in this column, 9 also only goes here and here, because 9 can't go in its own line, and this 9 blocks that. So this is an 8-9 pair, which means that this 2 must be 5, 7. But this can't be a 7, because a 7 would make this minimally a 10. So this is a 5, that's a 7. These have to be a 4, which can only be made of 1, 3. That removes a lot of options. This can't be a 5, this can't be a 3, this can't be a 1. Therefore this can't be a 2, because a 2 puts a 3 here. A 2 puts a 1 or a 3 here, which would eliminate all of these. So this can't be a 2, so that's a 5. That's a 6. I'm sorry if I'm not saying this very well, but this can't be a 1 or a 3. That's a 4. I hope you get what I'm doing here, though. I hope you get what I'm doing here. What is that? We haven't disambiguated this yet? Wow, okay. 7 makes that a 2. These are not 2s. That's not a 9, is it? It could be a 9. Why do I don't know what I'm doing. Yeah, we basically solved it. It's just regular Sudoku at this point. 5 is in one of those cells. These cells are in this row. These cells are 4, 8, 9. But this 8, 9 means that can't be an 8 or 9, so that's a 4. These cells are therefore 1, 2, and 5, along with this one. But I don't see anything to disambiguate that. These are 1, 3, and 4. This can't be a 4. This could be anything. Oh, look at this. What am I doing here? This is a 1, 3 pair, so that's now a 2. That's a 1. That's a 4. That's a 1. This is therefore a 7 in the column. This 7 means that is a 9. That's a 7. That 9 sees all of these cells. These are not 9, so that's a 9. That's an 8. That's a 9. This 8 sees that, so that's an 8. This is therefore, well, this is a 1, 3, so this can't be 1 or 3. That's a 4. This is therefore a 2. That's a 1. That's a 3. That's a 1. That's a 2. That is a 3. This 2 means that's a 1. That's a 3. That's a 1. 3 means that's a 5. That's a 3. 5 means that's a 2. That is a 5. This 1 means that's a 3. That's a 1. That's a 2 and a 4. This 4 means that's 2. That's 4. This 6 means that's 8. That's 6. This 1 means that's 3. That's 1. This 2 means that's 4 and that's 2. And solved. Okay. Barely 30 minutes. I'll take that, honestly.